Number 62, here we are. Love doing problems. Makes you feel good. Find the mass. All right, mass. All right, grams. And we're given moles. That's molar mass. Periodic table. And we're given the formula. All right, what could be better than that? Carbon, help me out here. 12.0107. I feel like writing all the digits times 5. Maybe not. I gotta punch these in my calculator. Okay, 12.0107 times 5. All right, we got 60.0535. No room for the units. Moles, grams per moles. All right, let's do hydrogen. It is 1.007994. Your periodic table might say something different, but 1.008 is fine. All right, there's 12 of them. Oh man, do I need to do this video over? Gonna run out of space. 12.09528. All right, this is kind of extreme. You just don't need these many digits because I know I got around to 3 sig figs. All right, let's add these up. Get the molar mass. 535.72.14878 grams per mole. And that's for pentane, which is C₅H₁₂. All right, the given value is 1.50 moles of pentane. Get rid of moles, put that on the bottom. Grams is what we, grams, what we want. All right, so we're going to put 72.14. I'm not going to have room. I want to round this off here. I'm sure it's not going to affect our answer. So let's cross out the moles. That number times 1.5 is going to be 108 grams. And there's your answer, 2A. All right, moving on. Let's do B. All right, B. Fluorine gas, so you gotta know your diatomic elements. Fluorine is a diatomic element, so that's 2 of those. I don't feel like doing this. You do it, and it's the same thing we just did. So I'm gonna go on to write it on to C. Okay, so all right, I'm feeling bad. Let me do B. Do B. B 14.4. Fluorine. 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 There's 2 of them. I'm not gonna write all these digits now. I'm just gonna go to 18 or 19.00. I think that is. All right, and there's 2 of them. That's going to be 38.0 grams per mole. All right, so what are we starting with? 14.4. 14.4. All right. 14.4 moles of fluorine gas. Get rid of moles, put that on the bottom. Put grams on the top. 38.0 grams on the top. Moles cancel out. All right. 38 times 14.4. Yikes, that's a big number. Is that what you got? Does that sound good? Yeah? All right. Cool. Got some confirmation here from Mr. Lee. That's right. There's another Mr. Lee here with me at this time of the day. All right, number C. What? Number C. Letter C. All right, calcium cyanide. So what do we need to know? Calcium cyanide is a polyatomic ion with a negative charge. Okay, calcium has a 2 positive charge, crisscross, and calcium cyanide is going to look like this. Oh, no way I'm doing all that on the... Okay, here we go. Let's do it. Calcium and 2 cyanides. Ugh, I'm starting to not like this textbook. Calcium, cyanide. There's 2 of them. Okay. All right. Calcium has a molar mass of 40.078 grams per mole. All right, carbon, there's 2 of those. Carbon's 12 points. I'm getting lazy now. Just going to go 12.01. Or 11, there we go. And there's 2 of them, right? Don't forget, we need to distribute that 2 outside the parentheses, and that's going to be equal sign. That's going to be invalid format. Times 2. 24.022 grams per mole. Right, then the nitrogen, there's 2 of them as well. Nitrogen is 14.01. I'm just going to start rounding the 4 digits. Times 2. 28.02 grams per mole. All right, how are we doing, Mr. Lee? Is it looking good? Checking out? You got it, Mr. Lee. All right, there's confirmation. We're on the right track. Let's add these up. Okay. I'm going to get phone calls from parents. 92. Okay, so there's the molar mass of calcium cyanide. All right, what was the original number that they gave us? Let's go check it out. 0.780 moles, 0.780 moles, 0.780 moles, 0.78. Did they give us a 0? They did. All right, 0.780 moles of calcium cyanide. All right, turn that into grams. How do we do that? Put moles on the bottom. And put grams on the top. That's why we do the molar mass. All right, punch. It's already stored in my calculator. Nice. 71.9 grams. That's how much you have left. Is that what you got, Mr. Lee? Mr. Lee's getting tired. We need another Mr. Lee. How about you, Mr. Lee? Come on, give me a thumbs up, Mr. Lee. No, it's wait, Mr. Lee. The other Mr. Lee's still working on it. He's getting slow. I made a new friend. All right, how many more? Is that good? That is good. Mr. Lee's finally caught. Oh, no way. We're doing all this other. Listen, class. I'm going to give you the formulas, and it's the same way. All right? That's enough of this. Hydrogen peroxide. All right, hydrogen is H. Peroxide is the O2, 2 negative polyatomic ion. So hydrogen, you can consider that to be a 1 positive. You crisscross that, you're going to end up getting H₂O₂. You can look up the hydrogen peroxide in your bathroom, and it'll tell you H₂O₂. So there you go. Sodium hydroxide. Let me get these started for you, because otherwise it's all the same. All right, sodium hydroxide. Nobody's going to watch this video. This is too much anyway. 62. I can say what I want. All right, sodium is Na. Hydroxide is OH. That's a polyatomic ion with a 1 negative charge. Sodium is a 1 positive charge, and then so it's just NaOH. Okay. Find the molar mass. Use the periodic table, and then do your conversion. Sodium hydroxide. Nickel is just an element, so just find nickel on your periodic table is number 26, I think. Oh, 28, sorry, 28, Ni. All right, 10 minutes.